Assalamualaikum. My name is Raja Razira binti Raja Muhammad Razalim. My metric number SB18068. Welcome to Group 4 presentations. So let me start with the background of the study. Our experiment, we collect the water from the Sungai Gading and also the Tasik Kambang. So we want to identify the water quality by record the parameters that assess in the water's quality. So they have three quality parameter, which is the physical, the characteristic, chemical, and also the biological parameters. So we take several of the parameter, which is temperature, DO, dissolved oxygen, the pH, conductivity, and also the turbidity for all the parameters that can evaluate the water quality. And also in this case, we also choosing to compare about our case study with the other case studies. So the purpose for the other case study is about they want to establish the water parameter for the water quality, but they collect the sample from the Balok, Pengora, and also the Kara River, which is located near. Okay, let me go to the second part in the part of the result and the discussion. In this experiment, the water sample from the Sungai Gading and also the Tasik Kambang were used to identify the pollution by the value of the TSS, total suspended solid, chemical oxygen demand COD, TN, total nitrogen, phosphorus, ammoniacal nitrogen, the pH value, and also the BOD value, biochemical oxygen demand. Okay, according to the result, let me go through one by one. For the pH parameter result, the data indicate that Tasik Kambang has the higher pH value than the Sungai Gading. The pH value represents the pollution and alkalinization. The Sungai Gading's pH value is near to the natural pH, which is 7.0. In theory, unpolluted streams should have a pH that close to the natural or slightly alkaline. So while the mean pH values in the Balok River, which is for the value for the other cases, they got around 6.61 until 0.24. This means the result indicate that most of the river water was slightly alkaline. So this value are within the usual range of the 6.5 until 8.0 for the freshwater ecosystem. So we done in our experiment all of the parameters to recognize the water quality is giving the different value for every sample that we collect. So I can conclude that the Sungai Gading is actually record the higher value of the contaminants and the pollutants compared to the Tasik Kambang. So we'll continue to the second presenter. Thank you.
Hi, my name is Chongzi, and my metric number is CB18126. Now, I will discuss to you about the conventional methods we use to treat our chosen case study, and also will propose to you about the bioremediation method we will use to treat our chosen case study. Okay? Now, let's start. The conventional methods we use are the biological treatment. The biological treatment is a cheap and efficient method used to degrade the organism. While its performance is greatly affected by the ratio carbon to nitrogen. The another conventional methods used is by the anaerobic anoxic process AAO in the hydrate retention time is extended. It is a biological treatment process that constantly uses many different types of microbes like the anaerobic and aerobic microbes to treat the leftover. It causes more intake of energy, so the so that the treatment effect can be enhanced. The alternative methods, such as the ion exchange, electrochemical process, and chemical process, are also the conventional methods used to treat the problem in this case study. However, these methods are inhibited by the low effectiveness to convert inorganic nitrogen to nitrogen gas. The ammonia in also treated with the photoelectrochemical technique, which is about 49.1% of which was converted to nitrate and could not be removed. So next, the bioremediation method we use to treat our case study. Since conventional remediation methods are unable to resolve the issues in the case study properly, so here we propose a new bioremediation method based on the catalytic reactions of hydroxyl and chlorine radicals to efficiently remove the total organic carbon (TOC) and total nitrogen from nitrogen-containing organic effluent, while at the same time also generate electricity. The bioremediation method we use is the wastewater fuel cell (WFC). So, based on the capacity to convert organics to carbon dioxide and nitrogen to nitrogen gas, enter a wastewater fuel cell (WFC) was developed employing a hybrid photoanode and lead copper and a cathode for the treatment of organic wastewater, including nitrogen, while also producing electricity under bias-free circumstances. The front and rear photoanodes were made of WO3 with a visible light response, and pack was made of commercial silicone PVC. A lead copper NF electrode was constructed using the electrode deposition technique, and the effects of various operating settings and end products on total nitrogen and phenol removal were investigated. So, the self-biased WFC proposed here enables the sustainable degradation of organic wastewater, including nitrogen, and at the same time can generate electricity for the practical purposes. Thank you.